Welcome to Stats with Chaz. I'm Dr. Charlie Collins. Today I will discuss confidence intervals. Today we'll cover what are confidence intervals, calculating confidence intervals for means, and calculating confidence intervals for proportions. So, to our first piece, what are confidence intervals? Confidence intervals allow us to estimate a population statistic, also called a parameter, within a range of values with desired probability of being incorrect or correct. For example, we often hear about the approval ratings of US presidents. The news may make a statement like, the president's approval ratings are at an all-time low at 38%. And then at the bottom of the screen, they'll have something that says something like plus or minus 3% with a 95% confidence interval. In this case, what they're saying is that the population statistic is somewhere between 35% and 41%, and that they are 95% confident that their sample accurately reflects this reality. Or, in other words, they give it a 5% chance that their sample does not accurately reflect the population statistic. Now, meet me in PowerPoint and I'll break down some of these components in more detail.
Okay, welcome to PowerPoint. We are going to move forward and talk about some confidence intervals and what those are. And so I'm going to break out the equation and provide an example here for confidence intervals. So first let's take a look at the equation. So here's our equation for confidence intervals. So CI in this equation means confidence intervals. Our X bar is the sample mean. Our Z is a Z-score that corresponds to our confidence interval or confidence level. This also corresponds to our percentile. So if you remember back when we talked about Z-scores correspond directly to percentiles. So we want to set our level of confidence based on the Z-score. And this small equation here is the standard error of the mean. And as you can see at the top of this equation, we have our standard deviation for our sample, and then that is divided by the square root of n minus 1, where n is our sample size. So here's what I mean when I'm talking about our confidence level. So it's up to the researcher to identify at what level he or she wants to hold their confidence, right? So as your confidence decreases, your range in your confidence interval will also decrease. As your confidence increases, your range will increase, and you'll kind of see what I mean here. So if you take a look at the Z-score column, that corresponds directly to a 90% confidence interval. So if you're to look at your Z table in the back of your book or online or wherever you get one, that Z-score of 1.65 corresponds directly to the 90th percentile. Accordingly, the Z-score of 1.96 also corresponds to a 95 for the 95th percentile. Right? So if we want to be 95% confident, which is standard in these types of measures, then we would use a Z-score of 1.96. Now let's just go through an example here. Let's say we're interested in the average number of Facebook friends for University of Washington Bothell students. All right, so we take a random sample of University of Washington Bothell students, and we calculate our confidence interval of the average number of Facebook students, or excuse me, Facebook friends for UWB students. So let's say in our sample our mean is 305.4. Our standard deviation is 20.3 friends. Our sample size is 100. And let's say we want to be 95% confident or have 95% confidence of this of the number of Facebook friends for UW students. So we'll start plugging into our confidence interval equation. And so as we've plugged in here, we've plugged in our mean, our Z-score, if we're going to stay at 95% confidence, and our standard deviation and our sample size. So if we can continue going down this path, we can start calculating each of these pieces correspondingly. So at the end here, we have a confidence interval of a mean of 305.4 plus or minus 4. Now what that means is, at the upper level, our confidence interval is 305.4 plus 4, which is 309.4. At our lower level, we have 305.4 minus 4, which gives us 301.4. So this gives us a range between 301.4 and 309.4. Now, what this is saying to interpret this is that, on average, University of Washington Bothell students have an average of 305.4 Facebook friends, plus or minus 4%, and we're 95% confident of this. Now, let's break this down a little bit. This isn't saying that all University of Washington Bothell students have between 301 and 309 Facebook friends. What this is saying is that if we were to be able to take the entire population of University of Washington Bothell students and get the mean from that, the mean would be somewhere between 301.4 and 309.4 Facebook friends. All right, so it's not that all students have this average, it's that the average of all students would be between this range, right? And our 95% confidence interval, what this is saying is that if we were to draw a random sample of 100, if we were to draw 100 random samples of 100 students, only 5% of those samples would fall outside of this range, right? Or fall out outside of this range, and would be inaccurate. So our chances of being inaccurate is less than 5%. So that's what this confidence interval is telling us. Now let's move on to confidence intervals for a proportion. Take a look at our equation for confidence intervals for a proportion. So here's our equation here, and it looks a little different than our equation for a mean, for a confidence interval for a mean. But let's break this down a little bit and see what each component is. So we have our confidence interval, CI. Then we have our sample proportion, and remember, a sample proportion directly corresponds to the percentage or the percentile. It's just 2 decimal points to the left of the percentage. And our Z is our Z-score, again, directly corresponds to our confidence level. This is exactly the same as our confidence interval for a mean. And then PU is the population proportion. Now, you might be asking, well, isn't this what we're looking for? And yes, it is. So there's a little bit of detail behind this that I'm not going to necessarily go into. Just note that we always set this to 0.5, right? Always, every single time. And so just know that. And so whenever you see this equation or need to calculate confidence intervals for proportion, this is what you're going to do. Always set this to 0.5. And N is our sample size, right? So again, we have our little table here, and let's maybe tinker with it and do a different confidence level. Right. So let's see, let's use an example here. So our example is proportions of students who have rented an e-textbook at some point during this academic year, right? This is fictitious data. I don't actually know the number to this. And so let's say that our proportion for the sample is 30 or 30%, right? So 30% of students have rented an e-textbook this academic year. Our sample size is 100. And now let's say we want to be 99% confident. So we use the Z-score of 2.58. Again, check in the back of your book. This 2.58 will correspond directly to the 99th percentile. In PU, we always set to 5. And here's our equation. So let's move forward and calculate this. So we'll plug in, I have a little typo here, but we'll plug in our 0.3, we'll plug in our z-score of 2.58, we'll plug in our 2.5s, and we'll plug in 100. And we get our equation here, breaking it down a little bit. And here's what we get. So our confidence interval is a proportion of 30 or 30% plus or minus 0.129 or 12.9%. Right? So when we break this down, we can start calculating our upper limits and our lower limits. So our upper limit would say that we have 30 or 0.30 plus 0.129. That gives us 0.429 or 42.9%. Our lower limit is 30, and that should be minus 0.129, and that gives us 0.171 or 17.1. Right, so what this is telling us is that 30% of UW students have rented an e-textbook this academic year, plus or minus 12.9%, right? And that gives us a 99% confidence interval. So as you can see here, this one is really wide, right? So essentially what I'm saying is that if this is true, if 30% of students have rented e-textbooks, what I'm saying is that based on my sample, our population, because I want to be 99% confident, our population parameter will range somewhere between 17.1% and 42.9%. So somewhere in that range is the accurate range, and I'm 99% confident of that. If I were to use 95% or 90%, that range would go down quite dramatically, quite significantly. So you can kind of play with that a little bit and see what that does for you. And that's what I have, so meet me back in real life.
That's all I have for this talk. By now you should know what confidence intervals are, how to calculate confidence intervals for means, and how to calculate confidence intervals for proportions. Thanks for watching Stats with Chaz. I'm Dr. Charlie Collins.